Okay, class. So let's go over the questions on page 599, 600, and 602. The first question we have are questions 9 and 10. And they're telling us that the diameter of a circle is given. They want us to find the radius. Well, here, the diameter is 15, and for number 10, the diameter is 6.7. Well, if you remember, we said that the diameter is twice as big as the radius. So the radius is just half the size of the diameter. So if a diameter is equal to 15 centimeters, the radius is going to be equal to 7.5 centimeters because the radius is always half of the diameter. For number 10, if my diameter is 6.7 inches, well then we're just going to take 6.7 and divide it by 2, which is going to give me 3.35. So for number 10, the radius is equal to 3.35 inches. For questions 13 and 14, it's the opposite. They tell us the radius of circle C is given, find the diameter. Well, if the radius is 26 inches, then I know that the diameter is going to be twice as big. So the diameter is equal to 52 inches. 26 times 2 is 52. For number 14, the radius is 62 feet. The diameter is going to be twice as big, so the diameter is going to be 124 feet. For question 17, they're asking us, which two circles below are congruent, and explain your reasoning. We'll take a look here. The radius of this circle is 22.5. The radius of this circle is 22. The diameter of this circle is 45. Well, if this radius is 22, then if I extend the radius the other way, the diameter is going to be 44. So we can see here that these two circles are not congruent. The radius of this circle is 22.5. If I extend the radius the other way and make a diameter, well then I can see here then the diameter of circle C, 22.5 plus 22.5 is going to give me 45, which means that circle C is congruent to circle C is congruent to circle G. Let's match up the corresponding parts in circle C. Number 18. Number 18 is a little bit tricky because if you notice here, see that line right there? That means a segment. Remember that. So when you're looking at this here, remember you're looking at segment AB. You're not looking at line AB, you're looking at the segment AB. And if you remember, this segment right here is touching two parts of the circumference, so that is a chord. So number 18 is letter B. It's a chord. H. If you look here, H is on this line here. It's just on the outside of my circumference. H is a point of tangency. It's touching my circumference. It's a point of tangency for line. We can call it line FH or line HF, or you can just leave it unnamed for now. The name is not important, but what's important is that you recognize that H is a point of tangency. So number 19 is going to be letter E. Now notice number 20. Number 20, we have the little arrows over the letters, so we know that that's a line. So they're referring to line HF. Well, if you look here, line HF, right, is tangent to circle C. It's also tangent to circle G, and it's on the outside of both circles. So it's a common tangent for both of them, and it's called a common external tangent. So number 20 is letter F. Number 21, again, notice that I have a segment symbol there. So it's just, we're talking about a segment CH right here. And if you notice, that is a radius. So number 21 is letter D. 21 is CH is a radius, which is letter D, yes. Letter D. Number 22, all we have is letter C. We can see here the letter C is at the center of the circle, which is why our circle is named circle C, and that is the center, and that is going to be letter A. Number 23, notice again, I have a segment symbol, so it's segment HB. HB, my segment HB is going from one end of the circumference to the other end through the center, And that is a diameter, ladies and gentlemen. So that is letter C. Number 23 is letter C. Number 24, again, notice the double arrows. So I am making reference to line AB. And here we have line AB. Notice how line AB is going through the circle, the whole line. So that is a secant line, which is letter H. And finally, it's obvious what number 25 is, line DE. Notice here that line DE is tangent to circle C, it's tangent to circle G, and it's going in between both the circles. So it is called a common internal tangent, which is letter G. Let's take a look at questions 26 through 31 on page 600. Okay. Here, they're asking us to tell whether the common tangents are internal or external. For number 26, I hope we can see that they're both on the outside of the circles, so they're external. For number 27, we can see that the point of tangency is inside there, so it is internal. For number 28, I hope we can see there that they're also going between the two circles, so it's also internal. For questions 29 through 31, they're asking us to tell how many common tangents the circle have. How many common tangents the circle has. Well, let's take a look here. I can draw a common tangent here. I could also draw another common tangent there. So that's 2. I could draw another one here this way. That's 3. And I can draw another one this way, which is 4. So these circles have about 4 common tangents. Question 30, number 30, they have no common tangents. These are actually, they're not even concentric circles. But I can't draw any tangent lines without actually going through the circles, which would make them, then it would be a secant line. So it would have none. And number 31, it says how many common tangents have? Well, they have 1, 2 points of tangency. They have 2 points of tangency. And if you wanted to draw some tangent lines on the outside, you could probably do that as well. Sorry, I put that. Okay, so that's about as much as you could do with those circles. Let's move on to questions 36 through 39. For questions 36 through 39, they wanted us to tell whether line AB is tangent to circle C, and they want us to explain our reasoning. So here is line AB. Here's line AB. Here's my line AB. Here's line AB, and here is line AB. And they want to know if my lines AB are in fact tangent to the corresponding circles. Well, remember that if they are tangent, then they would be what? They would be perpendicular to the radius. If these lines are tangent to this circle, then it should be perpendicular to this radius, should be perpendicular to this radius here, and this radius here. And if I do that, well then what I have, ladies and gentlemen, is a right triangle. So the Pythagorean theorem should prove whether or not this line is in fact a tangent line. Well, let's work it out. If these are the 2 legs and this is the hypotenuse, well then 14 squared plus 5 squared should equal to 15 squared. Okay. Oh, got some paper right here. Let's take a look here. Let's work this out. Is 5 squared times 14 plus 14 squared should be equal to 15 squared. Okay? Let's set up the Pythagorean theorem. 5 squared plus 14 squared should be equal to 15 squared if it in fact works. Well, 5 squared is 25, 14 squared is 196, and 15 squared is 225. When I add these two together, I get 221. It should be equal to 225, but notice 221 is not equal to 225. So then for question number 36, this is not a tangent line. The answer is no, it is not a tangent line. Let's take a look at question number 37. 37, they want to know if line AB is tangent to circle C. Well, if it is, then the Pythagorean theorem should work out. 5 squared plus 15 squared should be equal to 17 squared. Let's work it out. 5 squared plus 15 squared should be equal to 17 squared. Well, 5 squared is 25, 15 squared is 225, and 17 squared is 289. 25 plus 225 is 250, and we can see that 250 is not equal to 289. They're not equal, so the Pythagorean theorem does not work. So then line AB is not tangent. It does not work either. Let's take a look at question number 38. Question 38, if AB is tangent to circle C, well then 16 squared plus 12 squared should be equal to, well, let's take a look here, should be equal to 8 squared. I think we can clearly see that these two numbers added together are bigger than this number here. We don't even have to do the Pythagorean theorem. It's impossible that these two numbers added together are going to be smaller, or that 8 squared is actually going to be, is going to come from adding these two squared together. So right away, no. I know that doesn't work right away. Number 39 was a little bit tricky because here my line AB is 21. This radius right here is 10. So this radius here is also 10. So really this side of the triangle is 20. So if you want to see if this line is tangent, then it should be 21 squared plus 20 squared should be equal to 29 squared. Let's try that out. 21 squared plus 20 squared should be equal to 29 squared if line AB is tangent to circle C. Well, 21 squared is 441 plus 20 squared is 400, and 29 squared is 841. 441 plus 400 is 841, and we can see here that 841 is in fact equal to 841. So number 39 is yes. Line AB is in fact tangent to circle C. And now let's look at questions 46, 47, and 48. For questions 46, 47, and 48, we have an external point, and I have a tangent line I have a tangent line AB and tangent line AD, both coming from the same point. And if you remember the rule says that if two tangent lines come from the same external point, then those tangent lines should be what? They should be congruent. They should be congruent. Well, if they are congruent, we should be able to solve for x. So we can say then that 2x plus 7 is equal to 5x minus 8. Let's work that out. 2x plus 7 is equal to 5x minus 8. I'm going to subtract 7 from both sides. 2x is equal to 5x minus 15. I'm going to subtract 5x from both sides. That's going to give me negative 3x is equal to negative 15. I'm going to divide both sides by negative 3. And x is equal to positive 5. Let's take a look at question 47. Again, for question 47, I have two tangent lines coming from one external point. If two tangent lines are coming from one external point, then the two tangent lines should be congruent. So I can say then that 5x squared plus 9 is equal to 14. Let's work that out. 5x squared plus 9 is equal to 14. Well, I'm going to subtract 9 from both sides. 5x squared is equal to 5. I am going to divide both sides by 5. So then these cancel out and x squared is equal to 1. But I don't want x squared, I want x. Well, how do I get x? Well, I take the square root of x and the square root of 1. The square root of x squared is x, and the square root of 1 is 1. So x is equal to 1. And the last question, which is question 48. Again, I have two tangent lines coming from the same point, so they should be congruent. I know it looks a little bit long, but you've actually done this before. If you haven't, here's a little review. I'm going to set both of these equations equal to each other. So I'm going to write 3x squared plus 2x minus 7 is equal to 2x plus 5. The first thing I notice that they both have 2x's on both sides. So I'm going to subtract 2x from both sides. Subtract 2x from here. Subtract 2x from there. I'm going to get 3x squared. These cancel out. Bring down the negative 7 is equal to positive 5. Now I'm going to add 7 to both sides. 3x squared is equal to 12. I'm going to divide both sides by 3. And x squared is going to give me 12 divided by 3 is 4. Okay, well, I got x squared is equal to 4. But I don't want x squared, I want x. So I'm going to take the square root of both. The square root of x squared is just